Hello and welcome to our lesson on buoyancy and pressure, the science of force. So these are our three objectives that we're going to work through for this lesson. Each of these concepts will build on each other because essentially we're looking at how gravity pulls objects to the ground, how mass and weight are related, and how pressure can cause things to float through buoyancy. So the first idea we're going to look at is the Archimedes principle. And this diagram is fantastic because what it tells us is that if something weighs 6 pounds and it is placed in water, depending on the volume or the amount of space the object occupies, it needs to displace the same amount of water as its weight. In the case of the 6-pound weight, it displaces 4 pounds of water. Therefore, it still sinks. There's only 4 pounds of force being pressed upon it. It may fall slower as gravity brings it to the bottom of the container, but it is still going to fall. And that comes down to pressure. The force being pressed up on an object is the amount of water pressure pushing on the surface. So the smaller the surface area, the lower the pressure. The greater the surface area, there is more space for things to press against it. So as you go deeper into the fluid, more pressure can be exerted. So the pressure of water pushing on an object is part of how buoyancy works. So your first shout out, pause your video and think for a moment. What is the difference between buoyancy and pressure? Think about that. Now, if you said buoyancy is when the pressure equals the gravity of an object, so the amount of force or weight being pressed down is equal to the pressure allowing it to float, you'd be correct. And if you said pressure is the force of a fluid on an object, that would also be correct. Now talking about gravity. Gravity is what causes things to sink and fall. In air, a feather may fall slower than a larger object or a ball. However, if we put both objects in a vacuum where there's no oxygen or any other gases, they fall at the same speed. Gravity puts the same amount of force on all objects, and we call that a Newton. A Newton is amount of force. The force is always equal, so everything falls at the same speed. So when we put buoyancy and pressure into it, we can affect how many newtons are applied on an object, allowing it to float. So this goes back to the Archimedes principle. A ship has a certain amount of volume and weight, mass over space. So in order for a ship to float, it must be large enough to displace an equal amount of water to its mass. So if the ship weighed 50,000 pounds, it would have to displace 50,000 pounds of water. So you have to spread it out. So that's why a metal tanker ship that is enormous can still float, because it is large and spread out. And that brings us to our homework. Explain how a metal ship is able to float upon water. And that concludes our video.